All right, guys. Well, I just lost this video when I was getting ready to upload it. It quit right when I got to here, so I'll go back through it real quick uh, and see if I can figure out if I can get the other one back. But we'll go through it. So just remember, well, not remember now because you guys didn't see it to begin with. So when we're talking about pyramids and cones, actually, it'll give me the opportunity to redraw this horrible picture that I drew right here. So still, same idea. We always have to find the area of the base, okay? And the base on pyramids is either going to be usually a square or rectangle, or it's going to be some sort of a circle. And that's where we get a cone out of, or we get some sort of a pyramid that looks like this. So I will draw this one a little bit better than I did on the last one. Well, apparently not. I can't even get started. So the one in the book, and if you want a really good drawing, look at the one in the book. They have cool machines that do that stuff. So if we look at this, I know that my pyramid's going to have 4 sides, and I'll usually be able to see 2 of them like that. And that's even like the worst horrible picture. I didn't even start off right. It's just horrible, guys. So this is why Ms. Goodwin teaches art and I do not. So if we're looking at this and we have a pyramid, and so I'm just going to do this. So if you want to see a good one, page 927. That's where this picture is really good. So that picture comes from 927. So what we really need, though, is we need the base and we need the height. Now, I can draw it with just one side. So if we look at it from this point of view, and I have a base right here, the base is length times width, which is where I get my 20 from, okay? There it goes, where I get my 20 from. And then my height is the height that comes up here, and they actually say that's 6. Now remember, it's not the side of the triangle. It's the height from the center up to the spot where all of these meet. Look at that, I actually drew it. Forget that, page 920, I ain't even have the right page number, man. I'm just batting 1,000 right now. Lost my videos, I lost 50 minutes worth of calculus videos. Oh well, it is what it is. All right, so page 927, which now is right there because I've improved my drawing skills, tells us that the height is 6. So we have our 4 sides of the pyramid. So all we're doing, guys, is plugging it into the formula 1/3 base, the area of the base times the height. This one happens to be a rectangle, so 4 times 5 is 20. The height is 6, and so we get 120. And then from there, we get 120 times 1/3, and 1/3 of 120 is 40. Another way to look at it, 3 divides into 12 4 times, and we add the 0. Couple of ways to look at that, but just know I went through it a little quicker because I had these all written out because I lost my video before. But that's how they show you in on the page for 927. I don't know why I keep saying 4. All right, so now let's look at the cylinder. This is right when the video cut off. So if the video cuts off again, I know that it's some sort of bug when I say the word cone or something like that. It just freaks the iPad out. So what we need to know now, though, is when we're dealing with a cone, we know that the bottom is a circle. So now we've got the volume of a circle, which is pi r squared. That's our b, remember. This is our b. It's not over b, so let me draw that like that so nobody does that. Times the height. Well, we now know that pi times 4 squared times 10. That's 16 times 10 is 160 pi. Whatever, let's say this is feet. It's a big cylindrical cone. So now we've got 160 pi feet cubed. So remember, we're always dealing with the fact that we're looking for the base. If you notice, that's been a theme throughout this thing. We're looking for the shapes of the side of the base, and we're multiplying it by the height. When we're dealing with cones, it's not a straight, cylinder. So we got to take a portion of it, and that portion would be 1/3. So hopefully that helps you guys out. That is 15-5.